Hello and welcome to the part 2 video for the lesson Measurement and Motion. In the last video, we have learned about the importance of measurement, about the different systems of measurement, SI units and non-standard units of measurement, and how to convert from one unit to another. In this part, we're going to measure curves using the divider method as well as thread method. We'll also learn about how we can develop the skill of accurate measurement. We'll be learning how to compare between motion and rest. What is the difference between motion and rest? And we'll also learn different types of motion, how to classify moving objects based on their type of motion. When we talk about measurement of length, usually we use devices such as a ruler to measure length of a box, other such objects which are of a regular size. When using a ruler, there is a certain way in which the ruler needs to be handled. It has to be straight and it should be placed in contact and along the length of the object to be measured. That is, if the ruler is tilted and if it is not aligned along the length of the object to be measured, then your measurement can be skewed or inaccurate. So in figure A, the scale is along the length, while in figure B, it is not straight or it is skewed. Skewed means it is not straight. Another problem which you might have encountered is when your ruler is damaged towards the edges and you are not able to use measurements between 0 and 1 or 2, or towards the end of the ruler, the measurements in the last few centimeters of the ruler. So in this case, what do? We use the ruler from the first measurement, which is clearly visible, and then we take the final reading as well as the initial reading, and we take the difference, and this gives us the actual reading of measurement of length. This is something that you might have experienced in your practical life. For example, we are using an inch scale to measure this rod. The initial reading would be 8 inches, the final reading would be 10.5 inches, and hence the actual reading would be 10.5 minus 8 inches, which would give you 2.5 inches. And also, when measuring length using a ruler, it is very important that your line of sight should be directly above the measurement. That is, if it towards right or the left, then your measurement can also become inaccurate because you might be judging more or less than the actual measurement depending on the angle of your line of sight. Therefore, this is also an important point to consider when trying to make accurate measurements. Now let's see a short video on how we can measure a curved line. As you know, a curved line is not straight, and you cannot use regular objects such as a ruler to measure the curved line. An alternative method is using the thread or divider method, which will be explained using a short video.
Let us first understand how we can measure the length of a curved line using a thread. Draw a curved line. Take a long thread and put a mark at one of its ends. Place the marked end of the thread at the beginning of the curved line and press it down with your thumb. Trace a small length of the line with the thread. Press the other end of this traced thread with the finger of the other end. Keep on tracing the entire length of the curved line with the thread. Put a mark at the point where the thread touches the other end of the curved line. Now stretch the thread and measure its length between the two marks. This gives the length of the curved line. Now let us see how to measure the length of a curved line using a divider. Take a divider and separate its two tips by a small distance, say 1 centimeter, with the help of a ruler. Place one tip of the divider at the beginning of the curved line. Place the another tip of the divider on the curved line and put a mark at this point. Continue moving the pair of dividers forward till the entire curved line is divided into segments of equal length. Count the number of segments. If some of the part of the curved line is left over because it is less than the distance between the tips of the divider, measure it separately. Now let us calculate. The formula for the length of the curved line is equals to number of segments of equal length into distance between the tips of the divider plus length of the leftover part. That is equals to 7 into 1 plus 0.5. That is equals to 7.5 centimeter.
So I hope you've understood how to measure a curved line using the thread method or the divider method. Now let's take a look at what motion is all about. When you travel in a car or any other vehicle with co-passengers, are you in motion or are you in rest with respect to your co-passengers? Do the people who are traveling with you, do they look as though they are in motion or do they look as though they are in rest? What about when you look outside the window? The objects outside the window, like say a tree, a lamppost, or other people outside the car, do they look in motion or at rest? Motion and rest are very relative terms, meaning that it is always with respect to the surroundings or to some other object that we describe motion or rest. The people in the car are at rest with respect to each other and the car. Whereas the people in the car as well as the car, they are at motion with respect to the objects outside the car. Alternatively, the objects outside the car might seem to be in motion with respect to the people in the car. You might have experiences while traveling in a train wherein you might have got confused whether the train next to you is actually moving or whether it is your train that is in motion. Motion is the change in position of an object with respect to surroundings in a given time. Examples of motion are a moving train with respect to people at the station, a running horse, a moving ball, any object which changes its position in with time and with respect to its surroundings are said to be in motion. Two objects which move together are at rest with respect to other. For example, if you're pushing a trolley or a pram, the trolley or pram seems to be at rest with respect to you, whereas you as well as the trolley or pram are at motion with respect to a third person or who's at rest or objects which are outside surrounding. So rest is a phenomenon where an object does not change its position with respect to its surroundings in a given time. Now let's take a look at the different types of motion. Now look at this car. It seems to be at rest now, but when it starts, it moves in a straight line, and all the parts of the car, from the front part, the front wheel to the back wheel, covers the same distance in a given amount of time, the same amount of time. So all the parts of that object are covering the same distance in a given amount of time. That is, object moves together. All the parts of the object moves together in a straight line. So this type of motion is called as translatory motion. And because it is moving in a straight line, it is called as rectilinear. This is a type of rectilinear translatory motion. Now, objects might move together. All the parts of an object might move together also in a curved path, like this basketball which is being thrown and which is going to go around the hoop. So this ball is making a curved line and it is not moving in a straight line. But at the same time, all the parts of the ball are covering the same distance in the same amount of time. So this is still translatory motion, but instead of rectilinear, it is curvilinear motion. The motion in a curved path is called as curvilinear motion. Now, what do we see here? We see a rotating wheel. You're all familiar with the motion which is called as rotation, because we have seen it with respect to motion of Earth, and this is called as rotatory motion or rotational motion. The rotatory motion or rotational motion is the motion which happens when an object moves around its own axis. It's called as rotational motion. For example, the movement of the arrow of a wind vane or the movement of the hands of a clock are all in rotational motion. Now let's take a look at this barb which is moving to and fro, mean position which is at the center. This type of motion is called as oscillatory motion. Oscillatory motion is a to and fro or back and forth movement about a fixed point, or what we call as a mean position. That is, if you hold the position here at the center, the ball is moving in equal directions to either side of that central position or the fixed point. And this is what we call as oscillatory motion. Oscillatory motion can also be seen in another form, all sorts of wind instruments. For example, the drum or a violin or a guitar. When the skin of the drum is hit, or when the strings of the violin or the guitar are plucked, there is a very small movement, back and forth movement of the skin or the string, and this is what we refer to as a vibratory motion. This is what we refer to as vibratory motion. So vibratory motion is a type of oscillatory motion. Now, not everything in nature has a planned path of movement, like the bees or the butterflies or the birds in the sky can move randomly in any direction and can also rapidly change the speed of their motion. And this type of motion is referred to as random motion. The random motion is a type of motion in which the direction and the speed of movement keeps changing. Like also the movement of a football player on the football field, the direction and the speed of movement keep changing. The types of motion that we see in this slide can be classified into two types if you observe very closely. The movement of the hands of a clock, the movement of the earth around the sun, the movement of the earth around itself, that is the rotational motion of earth, the revolutionary motion of earth, the rotational and revolutionary motion of the moon. They all follow a time, all happen in a given time, in a fixed period of time. This type of motion is referred to as periodic motion. And if you look at the way the mother sways the cradle of the baby, the speed and the frequency of the motion can change. That is, the speed with which the um, mother sways the baby to and fro can change, and it is so many oscillations per minute. It can vary. Therefore, it is called as non-periodic motion. It does not repeat itself in equal intervals of time. So it is called as non-periodic motion. Periodic motion is when the motion repeats itself after regular intervals of time. For example, the motion of a swing, the motion of the needle of a sewing machine, the motion of a guitar, the motion of the hands of a tabla player on the tabla has to be periodic motion, because if the motion is not periodic, then the tone changes and the music would not sound so rhythmic. Rhythm in music is all about periodic motion. And when the motion does not repeat itself after regular intervals of time, this is what we refer to as non-periodic. Example, the vibration of the eardrum, of the ear or ear ossicles, the clouds moving across the sky are all examples of non-periodic motion. Now, not everything in nature follows just one type of motion. For example, if you observe the way a ball moves, what are the different types of motion that we can observe? A ball has both rotational motion as well as it could have either rectilinear translational motion or curvilinear translation. The The hands of a fan can also have rotational motion as well as periodic motion because it is covering the same number of rotations every minute at a given speed. It is also having periodic as well as rotational. The movement of a bicycle also shows multiple motions. The movement of the wheel is rotational, and it is as well as translatory rectilinear motion when it is traveling in a straight line. Suppose it is making a curve, it would be rotational as well as translatory curvilinear motion. Let's try to classify the motions that we see here, different types. The motion of the earth will have rotatory as well as periodic motion. Motion of the football would be translatory, rotatory motion. The motion of a train arriving at the station would be rectilinear translatory motion. Motion of merry-go-round would be circular motion or rotatory motion. Familiar with rotatory motion. And the motion of a runner who's making a curve would be the motion. The motion of bouncing ball, which is just dropped, would be rectilinear. The motion of children swinging would be oscillatory motion. Let's recap what we have learned in this lesson. We have learned how to measure distances accurately, lengths accurately using a ruler. We have also shown how to measure the length of a curved line using the divider method as well as the thread method. The concepts of motion and rest in the different types of motion, translatory motion, oscillatory motion, periodic and non-periodic motion, random motion, and we've seen how most motions are the result of. That brings us to the end of this chapter, which is going to be a very foundational lesson physics when you learn about motion. So I hope you have understood the concepts pretty thoroughly, and see you again in another video, another lesson. Bye bye and keep learning.